Hello and welcome. So the article that we're going to be talking about today is called Pulsatility Hemodynamics during speed modulation of continuous flow total artificial heart in the clinic in vivo model. So here we have a total artificial heart designed by Cleveland Clinic Foundation. So and basically this heart is an electric is an electric motor right over here. And it has this electromotor works in two chambers, one on the right and one on the left, mimicking the normal human heart, which has a right chamber and a left chamber. So the right chamber, it pumps deoxygenated blood from the right atrium to the pulmonary artery, whereas the left chamber pumps oxygenated blood from the left atrium to the aorta. So, if we leave this electric motor at a constant speed, as you can see here, there is no, the flow is going to be constant and there is not going to be, uh, there is not going to be pulsatility. So there is not going to be a systolic and diastolic pressure. And this doesn't mimic the normal human physiology. Uh, uh, and this because the lack of systole and diastole may damage the endothelium and can cause some issues. So we need to create some pulsatility. And so the way that this pulsatility can be achieved is by increasing and decreasing the pump speed in cycles. And this can be done by giving more and less electricity to the pump. And there is like you can do that in certain degrees. So if we take, for example, a 30% modulation, um, if we take a 30% modulation, so in other words, if the pump speed was increased by 15% and then decreased by 15%, and then we go like that in an 80 pulse per minute uh, heart rate, mimicking the normal physiology, we can notice that the pump flows actually goes up and down as expected. And we can also see that the aortic pressure goes up and down in systole and diastole, uh, like the normal physiology. And also we can see this systole and diastole in the pulmonary artery pressure. So this is the diagram of the artificial heart. So you see here is the right the oxygenated blood chamber, and here is the left oxygenated blood chamber. So in this Cleveland Clinic artificial heart, one of the latest models, it has a nice characteristics called axial movement. So the motor goes right and left freely. And so, for example, if the left pressure was higher than the right pressure, the pump, the motor will go to the right. But if the right atrial pressure was higher than the left atrial pressure, then the motor will go to the left. And by the way, there is a magnet, so that it's gonna pull the motor back to its original position after it moves, stabilizing it. And the benefit of this characteristic is to balance the right and left sides of the heart. And this characteristic was proved in vitro. So in this diagram, you see when the left atrial pressure is higher than the right atrial pressure, the rotor position goes to the left. But when the right atrial pressure is higher than the left pressure, the rotor position goes to the right. And so in this article, they planted this total artificial heart in a lamp, and they did some physiologic studies. So by the way, the systolic minus diastolic is the pulse pressure. Um, so here the diagrams we're talking about pressure, so we're not talking about pump speed, we're not talking about the pump flow. So here on the x-axis we see the percent modulation we talked about earlier here, and on the y-axis we have the aortic pressure and the pulmonary artery pressure. So if we look at the aortic pressure diagrams over here, the only statistical significance those researchers found was when they used the percent modulation 30% and when they used the percent modulation 35% in the pulse pressure. So they found the highest pulse pressure. But when they looked at the pulmonary artery pressure diagram readings, the only statistical significance they found was at the 30% modulation and the 35% modulation the systolic pressure, and at the 25%, 30%, and 35% modulation at the diastolic pressure, and at the 30% and the 35% modulation in the pulse pressure. Um, I hope you like it. You like this review. Thank you so much for watching.